What is up everyone? Hope everyone's having a beautiful day so far. So for today's video, we're going to be talking about what power factor is. Alright, let's get to it. So what is power factor? Well, power factor is defined simply as the current going through the load. But the direction of the current is determined whether the power factor is leading, where the current leads the voltage, or lagging, where the current lags the voltage. If it leads, then it's typically found in the capacitive circuit. However, if it lags the voltage, then it's typically found in inductive circuits. Now I know all of this sounds very confusing, but stay with me now as we move on to the mathematical side of things. So power factor is usually given in the formula as FP, of course just meaning power factor, which equals to P over I, where P is your real or average power over the apparent power of VI, where your values of VI are actually going to be your RMS voltage and your RMS current. Now there's one more thing here that's missing. That. So the theta, or angle as you call it, is the phase angle between the voltage and current waveforms. So now that we have this formula, let's use it in a few examples. So for our first example, we are given this diagram where the current of this value is going towards the load of the voltage value. So what is FP? Well, FP is given in this formula for this question. Since we are working with two angles, we're going to change the cos to the absolute value of the angle voltage minus the angle current. Sorry, that's an absolute value. So FP will now equal to cos of the absolute value of 40 minus 20 degrees, which gives us cos of 60 degrees, which gives us 0.5. Since the current angle is negative, we can say that the power factor is leading the voltage. So for our second question, or second example, we are given a picture. To make this easier, I've drawn the same diagram as question 1. So, in this case, we would be using the same formula again from question 1 of FP equals cos of the absolute value of the angle voltage minus the angle current. In this case, it will equal to cos of, using our values, 80 minus 30, which of course gives us cos of 50 degrees, giving us the final value of 0.64. Now because the angle of the current is smaller than the angle of the voltage, then we can say that the FP, or the power factor, is lagging the voltage. As you can see in example 3, we are given both the effective current and the effective voltage values. And now we are also given the average power value. So what is FP? Well, in order to find FP, we would be using this formula instead of FP equals cos. And that would be FP over VI. So FP will equal to 100 watts over 20 times 5, which is equal to 100 over 100, which, if you know, will just equal to 1. In this case, the load is resistive, and FP is neither leading or lagging. That's your final answer.